Welcome to the Neutral Podcast, where we discuss paving the way to a sustainable tomorrow. I'm Nate Habenbacher, your host, founder, and CEO of the Neutral Project, a sustainable real estate development company. Join us each week as we host world-renowned guests and explore dynamic landscapes of real estate development, alternative investing, sustainability, forestry, urbanism, and new cutting-edge carbon-neutral construction materials that are shaping the cities of tomorrow. Welcome back, everyone, to the Neutral Podcast. Today, we're going to talk about forest management and mass timber, and I'm joined by Johannes from KLH, and Johannes is the Chief Technology Officer of KLH. KLH is based in Wolfsburg, Austria, and we're actually using them for one of our projects here in Madison called Baker's Place to source all of the mass timber. Maybe, Johannes, you could give just a little background on yourself before we dive into more about the company and KLH.
Yes, perfect. Nate, thank you very much for this kind introduction. So, my name is Johannes. I'm the Technical Director of KLH. So, I'm with KLH since more than almost 17 years. And from my background, I'm a structural engineer. So I finished my studies, civil engineering, at the Technical University of Graz. After that, I was working for 11 years at a Q-lamp producer. So a company that was specialized on curved Q-lamps or long Q-lamps up to a length of 30 meters. So we did nice structures for industrial buildings, but also multi-story buildings. And since 2007, I'm with KLH. I've started again here as a structural engineer, but then additional topics came up like certifications, like project management, different technical things, R&D activities. Yeah, and so I'm happy that together with my team, I had all these technical things here, and I'm looking forward to the discussions we will have today.
Same here. Yeah, well, I think where we want to start in our segment one is just to talk a little bit more about KLH. And I was just in Austria about 3 weeks ago with Johannes, and he gave me a factory tour. But before we started, he gave me some background on KLH, and they're like the founding fathers of mass timber. So I'm looking forward to have you tell our audience a little bit more about that.
Unfortunately, I was not part of the team at that time, but this history is really famous. At the beginning, 3 sawmill owners from the region decided to establish a new business and to invest research activities into this new product, which was a cross-laminated timber. So at the end of the 1990s, big research project started at the Technical University of Graz with the aim to prove if cross-slice curing of lamellas is working well and if it is possible to produce large elements in an industrial way. And after finishing this research project with a very good outcome, the production started at the end of the 1990s. And then a small company was established to produce cross-laminated timber elements. And after a short period and after a very successful start, the company was growing and growing. And so today we run in total 2 factories and we produce and deliver the elements worldwide. So it's a big story of success thanks to the founders and for their innovative ideas to produce a new product, which is CLT.
That's awesome. One thing you shared was a lamella, which I think might be an unfamiliar term to a lot of people. Could you explain a little bit more of what the lamella is?
Yeah, this is the raw material. Yeah, so we use lamellas to produce cross-laminated timber. It's similar to 2x4, not 2x6 or 2x8. So it's a board we get from the saw industry. So we buy spruce boards, spruce lamellas, in accordance to quality criteria. They are already kiln and dried. And this is the raw material we use for CLT production. So what is the word you use?
Lamella?
Lamella? Yeah.
No, it's the same word. I think a lot of people are more used to in America the use of like a 2x4 is probably what they understand, and they'll go to like their local Home Depot, which in the US is like a big timber and like construction conglomerate, and they'll go buy like a 2x4 for their house when they're doing renovations. One thing I wanted to ask was, what is KLH's commitment to like sustainability? Because I understand that the kind of impetus of KLH was from these 3 timber manufacturers and sawmills, and obviously there's some economies of scale when it comes to CLT and producing that if you're a sawmill or producing wood. But what is KLH's commitment to sustainability?
So we produce a natural product. Yeah, we produce mass timber elements from natural softwood. So that means, for sure, we also want to not only to deliver an environmental product, we also want to be environmental in our production process. And our commitment is also that we exclusively use raw material from sustainable forests. We exclusively buy raw materials from our partners, which is certified, which is controlled, which is legally harvested. We try to have a look on short distances. That means the carbon footprint in the forest, on the street, on the road, and that the sawmill should be as small as possible. And for sure, our production also should work most efficiently to avoid waste, to save energy, and also to keep the carbon footprint as low as possible.
You talked a little bit about the kind of process and journey of the timber from the forest all the way to the sawmill to the factory. Can you explain a little bit more about, like, are you guys sourcing your timber from Germany or other parts of Europe, or is all your timber sourced locally in Austria?
Our timber is sourced locally. So we are in the good position that within our group, we also have our own sawmill, which is producing a lot of nice sawn lumber that can be used not only for CLT production. So that means we get, let's say, 50% of the raw material from our own sawmill, which is close by, and we source the other raw material that is needed from other sawmills in the neighborhood. That means the delivery distance between LH and the sawmills is already small. All our suppliers are in Austria, so the radius to the sawmills is, 100 kilometers, 150 kilometers mean value. And the sawmills again source the logs also in their neighborhood. So the logs come from forests in Austria, or maybe a bit on the other side of the Austrian border, but it's altogether, it's locally sourced raw material. I guess that the mean distance from the forest to KLH is 150, 200 kilometers. We do not source lamellas from Northern Europe or from other countries in Eastern Europe. We exclusively source local raw material.
Yeah, just to transfer that into the U.S. metric system, that's only about 93 miles from the factory. So 93 miles is their average sourcing distance for timber, which is amazing because you're then cutting down on a lot of emissions from the trucking of those logs to the factories. That's cool. And so then once it goes to the mills, which it sounds like some of these mills are the owners of KLH from the start, where does it go after that? Like, what is the process that it goes through?
What is the process after arriving of the raw material at our factory, right?
Well, before it arrives at your factory, right, it gets taken down in the forest into these huge logs. How does it go from the logs to the lamellas?
Yeah, so we are in the good position that in our region we have a lot of nice spruce trees, and we are still in the good position that more timber is growing in the forests than we need for different purposes. So the sawmills can buy the logs from the forest owners. Then special teams in the forests are cutting down the trees. Due to the hills and mountains we have, it's usually handwork. That means it is not possible that big machines are working in the forest. So it's again a bit more sustainable and environmental friendly. And after that, the logs are transported to the sawmills. And then at the sawmills, they sort the logs due to the different diameters in different categories. And then they already try to cut as much sawn timber from one log. So the sawmill is already trying to avoid waste and to be as efficient as possible. So that means from different diameters, they get different sawn timber, different dimension, different board sizes, already the first step in being efficient in raw material use. The second step will be, after cutting the logs into sawn timber, the first visually process is starting to prove the quality of the raw material. And after that, the lamellas or the boards get dried. Or in Austria or in our region, the sawmills have their own kiln and drying equipment to bring down the wood moisture to a level that can be used in CLT production. So that means that we already get nice packages of sawn timber that are already visually controlled, visually pre-graded, and the wood moisture is already down to a wood moisture percentage of about 12% plus minus. And so this lamella can be used, or this material can be used perfectly for CLT production.
And that's what you're getting then delivered to your factories from the sawmills, is those lamellas at a moisture content of plus minus 12%.
Correct.
Interesting.
The drying process is already done at the sawmills. So KLH, we do not have our own drying equipment. So it must be secured that the raw material we buy is suitable for CLT production. Otherwise, it would be waste. KLH is producing cross-laminated timber exclusively. So unfortunately, we do not produce other products like, I don't know, columns or other thin pals. So we are the specialist in cross-laminated timber. It's again the goal to avoid waste from the beginning.
And you talked about the grades of these lamellas that you're getting to your factory. Are you buying multiple different grades? Or are you buying one grade? And how is it sorted? Is it sorted at your factory, or is it sorted at the sawmill beforehand?
Yeah, that's a good question. Yeah, so as I mentioned before, we buy locally sawn timber, sawn timber that is locally grown. And we see that more or less all the boards have similar mechanical performance. So from mechanical perspective, we only have one grade. We only have one strength grade, which is C24 or better. So that means if we again grade each lamella at our production, then we just recheck lamellas with lower mechanical grade, but we use each lamella that is at least C24 or better for panel production. And then in addition, we differ between lamellas that can be used for visual top layers or for non-visual top layers or for inner layers. So that's an additional grading process. All of the lamellas fulfill C24, and on top of this, we differ between lamellas that can be used for visual surfaces or maybe just for inner layers or for non-visual templates. Especially, so I've mentioned during our visit that we have seen it, that we have built a second factory 3 years ago. And there we also had the discussion, should we use more than one strength grade, or is one strength grade of all lamellas good enough? And we ended up with the decision to use just one strength grade, because otherwise all the logistics in the production process would be very complicated, and you would need a much bigger factory if you have 2 or 3 strength grades at the raw material. So at the end of the day, it was also an economic decision just to use one strength grade.
So you have one strength grade that you're buying from these sawmills, but then once they get to factory, the lamellas, you're actually sorting for visual grades, so you know what lamellas to put in the middle and what are the top layers?
That's correct. So in accordance to our requirements for the lumber sourcing, if the lamellas arrive at LH, we again do grading on each lamella. That means if we start the production process, we improve the performance of each board that is going to the production. Therefore, we have a nice equipment. So we do machine grading. We have golden eye equipment from the company Microtech, and each lamella has to pass this machine, and there we prove, on one hand, the mechanical performance of the board, if the C24 criteria is fulfilled or not. And in addition, we also prove if the surface of the board is nice, or if we have deviations in color, or what we measure the knot sizes, we measure the growth ring sizes, and then the machine is deciding if this board can be used for top layer, inner layer, visual layer, non-visual.
Well, and so then once the board comes into the factory, could you explain like how, because I mean, I think a lot of people see these boards that are usually 8, 9, 10 feet long, and they wonder how then the panels are 30 or 40 or even 60 feet long. So how do you take a board that's very small, 2x8 or 2x10, and turn it into this big 8x30 foot panel?
I hope I can explain it in the right way. Also, you have seen the production. You know what I'm talking about. So at the beginning, we start with these boards, and usually they are 4 meters long. So this is a standard length, and we have different cross sections of each board. First step will be the machine grading process, as I have explained. And after that, the boards move to the finger jointing line. And finger jointing means that we glue together the lamellas lengthwise. So we have a machine that is doing a profile at the ends of the lamella. Then we apply adhesive to the edges. And then in a special press, we press the boards together to get an endless board. And with that process, with that machinery, we can produce finger-jointed lamellas with a length up to 16.5 meters. And this is also the maximum panel size we produce. So the first step will be to finger-joint the boards to get finger-jointed lamellas up to a length of 16.5 meters. And these lamellas can be used for the panel production.
And then once it goes through, so just so everyone's on the same page, the lamellas that he's talking about, they're only about, 2 feet wide, like 1 meter wide, and they're very long. So 16 meters long is roughly 45 feet, but they're not that wide. So then once they go through that first finger jointing, they go through the press. Is that correct?
That's correct. So the first step is to glue the lamellas together lengthwise. So the single board is small. So the width of a single board is, let's say, from 10 centimeters to 28 centimeters, which is less than one foot. And after finger jointing the lamellas, the next step in the production is to edge glue the lamellas to get a sheet a single layer sheet that already has the size of a master panel. So at our factories, we are able to produce master panels up to a length of 60.5 meter and a width of 3.5 meter. So this should be 12 feet in width. And in preparation for the panel production, we edge glue the single lamellas, and then we get a sheet that is that has the thickness of one layer in the panel and has already the size of the master panel. So this is the second production process of the finger jointing. Second process is this edge gluing, and then these layers are prepared for the pressing process. That means if a KLH panel consists of 3 layers, then we have 3 sheets that move to the press. If it's a 5-layer panel, then 5 sheets move to the press. And at the press, we clean the surface again. Then we apply the adhesive, bring all the layers together, and then the package of lamellas is moving to the press. And then after pressing this package a while, then we have a master panel that is hardened, that can remove to the CNC cupping lines, and then this is already the cross-laminated timber element that is load bearing.
So if it doesn't have to go the CNC line, it could just go right out the door, right? And that would be the final product?
Could be, yeah. So if we have some customers that are buying the master panels, some of our customers have their own CNC equipment. So this is one option, that we produce the master panels and the CNC cutting is done at the production lines of our customers. Or the master panels are moving to our own CNC lines. So we have in total 4 CNC lines at one factory, and we have 3 CNC lines at the other factory. And with this CNC lines, the machine is doing the final job on the master panel. So this machine is equipped with different tools, sawmills or drilling equipment, saw blades, and then the machine is doing the cuts on the edges of the panels, window openings, door openings, grooves maybe that are needed for electric cables, wall holes, whatever is needed. So this is a automized process, and at the end we get the single elements that can be transported to the site.
And that's what we just saw on Thursday, well, I guess we saw it 3 weeks ago, get pressed in factory.
Yeah.
So I get shipped across the ocean and transported to site, and it showed up on Thursday at Baker's place. So
yeah,
pretty cool to see from the 2x4 or 2x8 all the way through the factory and then all the way to site. So we got to see the whole process. One point and nuance I want to talk about a little bit is the adhesive, because I know this can be quite troublesome for some European factories, because in the US we have something called PRG 320 certification, and Europe has a different standard that they have to adhere to. But for the audience that doesn't know what PRG 320 is, it's basically a standard that allows CLT to be used as a structural element in buildings in the US. And I'm forgetting what they use in Europe, but maybe Johannes can remind us. But maybe walk us through a little bit of the difficulties around getting PRG 320 certification for a mass timber manufacturer.
Yeah, so that's correct. So we have different standards that are used in Europe and in the US. So in the US, as you mentioned, it's the PRG 320 standard that is used. And in Europe, it's either a European standard, a Eurocode standard, or we deal with European technical assessments that can be used as a basis to produce and deliver the elements. The big challenge is that not only the product CLT must be certified in accordance to the European systems or to the US systems, but also the adhesive. So that means KLH is using polyurethane adhesive, which is used by most of the CLT producers because it's free of formaldehyde and free of emissions, and it can be used without additional temperature at the production lines. So that means you can process the adhesive with cold presses at the end of the day. So some advantages. But on the other hand, this adhesive must also be certified in accordance to the European systems, but also in accordance to the PHE 320 system. Unfortunately, we have to switch the adhesive. So we use a different one if we produce for the US market, and we switch the adhesive if we produce, again, panels for the European market. So the production line must be able to deal with at least two different types of polyurethane adhesives. And for the US market, we use this so-called HDX adhesive, which is approved. And it's also an advanced adhesive, I would say, that is heat resistant. And that's, again, beneficial for the layer performance of the CLT elements. So that means in case of some what temperature, this HDX adhesive will remain stable. And at the end of the day, you will have a constant burn rate in case of fire, which makes life easier for the structural engineer or for the engineers that are doing the fire design on CLT. So if you come back to this adhesive, so all of our equipment is established and built in accordance to the requirements to use polyurethane adhesive, and we are able to switch from the HPX to the European version if we produce either for the US market or for the European.
And so the HPX is for the US market, and I think is it called HP is the one that's used for the EU mostly?
In Europe, we use the HPS.
HPS.
As a standard, yeah. But in the meantime, the HPX is also approved for Europe. So, in Europe, we use either this HPS or the HPX. So it depends on the requirements.
And both HPS and HPX are polyurethane based, correct?
That's correct. That's correct.
So why if you can use HPX for the European market, why has most Europeans not switched to using just HPX?
Yeah, this is it's still quite a new topic, and maybe in the future we will do so. At the moment, it also depends on the availability of the adhesive. Yeah, so it's also for sure a question of price at the end of the day. Yeah, so the HPS is at the moment a bit cheaper than the other one. So for different reasons, we switch between the adhesives. But maybe in the near future, we have one adhesive that is covering everything. Yeah, we will see. So we see that also the producers of the adhesives are innovative and they are working on improving their products. So I'm sure that maybe the next generation of adhesives, of polyurethane adhesives, can be used more individually. Yeah, so that we can use it for both the European and the US markets. And I think the next generation of adhesive will be heat resistant in many cases. But this will take some time. Yeah. So it's a process, and the things are developed.
And what's the major difference between the European HPS and the US HPX adhesive?
At the end of the day, the test procedures are different in Europe and in the US. And so I'm not a chemical expert, but the HPX is a bit more heat resistant to be able to pass the test protocol in accordance to the PHE 320. And the requirement in Europe is a bit different. So with the HPS, you also can match the European requirements. But we will see, maybe in 1-2 years, we will have another next generation of adhesives that is covering both. I hope so.
Yeah, it sounds like it would be a little bit more convenient for your manufacturing process just to have one instead of switching back and forth.
Yeah, in regard to efficiency in the production, it would be better to have just one adhesive. On the other hand, we are already used to switch from one to the other. So, yeah, so at the moment, we are happy with the solution in our production. It's working quite well.
Good. Okay, I want to move on to the next segment, which is a little bit more going back to the forest and understanding more about the forest management and how involved KLH is with that. So maybe just for a brief second, you could kind of explain the amount and level that KLH gets involved with the forest owners in their forest management.
Yeah, sure. So unfortunately, we do not own our own forests. Yeah, so we always have to buy the logs or the lamellas from forests that are owned by different owners. What we do to make sure that we are environmentally friendly, KLH is certified in accordance to both PEFC standards and FSC standards, and we exclusively buy raw material that is fully fulfilling the criteria in accordance to PEFC or FSC. And with this certificates, we put some pressure to the sawmills. So the sawmills are also forced to buy logs from forests that are sustainable managed. So each log must be harvested legally, and all the documents must show either PEFC or FSC as a proof of environmental friendly or sustainable forest management. So with our PEFC and FSC certificates, we guarantee that the logs are coming from sustainable managed forests. So that's how we manage this in regard to log sourcing. In addition, we try to keep the delivery distances short, as I've mentioned before, and for sure, we try to avoid waste. We try to use the raw material as efficient as possible to reduce the percentage of waste we have in our production process, to keep the amount of raw material as small as possible.
A few points I want to touch on there. The first one is in regards to PEFC and FSC. Those certification processes, they require that the forests go through like a very kind of robust certification. And so with that, are you kind of leaning on those organizations to make sure that the logs you are getting are PEFC and FSC, and that's kind of like the stamp of approval? Or are you actually going to the forest like managers and kind of talking with them and engaging with them to understand a little bit more about their forest management?
As in Europe, we are in the good position that we have very good forest regulations with a very good forest law. So with this kind of certification, it's not necessary that KLH is going to the forest or proving something directly at the forest, but we prove that everything is okay from the sawmills, and the sawmills prove that everything is okay in the forest. So at the end of the day, with this chain of custody, we have the proof from the forest to the CLT product that everything is fine. So on one hand, we trust the PEFC and the FSC certificate, and we do annually audits and we prove that each lamella is certified, that is coming from the sawmills and that is used in our CLT product.
Cool. And so if like a client asked you, could I get a chain of custody certificate, that you would be able to produce that on almost every single board that you're producing in CLT panel?
We would not be able to produce a certificate on each board, but we have a certificate on the overall volume we produce per year, and we know from which countries the logs are coming from. And so, as I already mentioned before, so about 95% of logs are coming from Austria, and only a very small percentage from the neighborhood around of the borders of Austria. So it's quite easy for us to prove or to show to our customers that the logs are locally sourced.
Very cool.
Yeah.
Yeah. One other thing I wanted to touch on was after I got back from Austria, I actually went and toured a manufacturing facility in the U.S. And I've toured a few other ones in the U.S. as well. And it was eye-opening to see the difference between your process and the U.S.'s process. Because in the U.S., they don't recycle the waste, which I found a little bit annoying, to be honest. I was like, we should be using the waste. And so maybe you could explain how KLH uses all the waste, and just so the audience understands, when you're producing these CLT panels, you do have some waste. And so obviously it's still wood and we can still use it because it's a natural resource. It just isn't able to be used for the CLT panel. But yeah, maybe you could talk a little bit more about that.
Yeah, that's a big topic. Recycling and reuse of these different raw materials. So that's a big aim also for us to have a good solution at the end of the day to use all the waste we have during our production process for reuse or recycling at the end of the day. So yes, on one hand, some material is used for pellet production, for example. Yeah, so we sell some of the waste to other companies that are producing heating material. But on the other hand, if we have some window cutouts or door cutouts at CLT panels, we try also to use them for stairs or for furniture or for other reasons, or to produce equipment in our production. So each element that cannot be used on site should be used for a different reason. So this is our goal at the end of the day. And we are working on the topic how to reuse maybe CLT or how to recycle CLT. So this is something for the future. And I hope that we also have solutions that reuse and recycling can be implemented into the industrial production process. So today we are not able to do this in this industrial way, but I hope that we will be able very soon also to deal with recycling and reuse of CLT.
Yeah. I want to come back to that reuse of CLT, but before we do, just so we understand this process a little bit better, on the line when I was in the factory, I kind of noticed that on every single spot where you were cutting wood, whether it was a lamella or a CLT panel, you had this really cool system that went through the whole factory that actually pulled the pellets almost. Well, they weren't pellets yet, but they pulled the scraps out to make pellets. And so those pellets that you're producing in factory, are you just selling those to like local Austrians so that they can heat their homes, or what are you doing with those pellets?
That's correct. So at the moment, we sell these pellets to other companies that are producing heating chips or heating pellets. But again, this is a raw material that maybe can be used in the future for other reasons. Yeah? So maybe this can be used as a raw material to produce thin kind of plywood boards or whatever. We will see. So today we have two different visions. On one hand, the vision is to reduce the volume of waste that is coming from the production. And the second thing is to find a solution beside heating this material, what can be done in a different way so that we can recycle or downcycle or maybe upcycle this waste that is coming from CLT production.
And what technologies are you guys envisioning that you would use to reduce the amount of waste?
Yeah, so raw material efficiency is a big deal. So what can be done? On one hand, if the incoming material is already in a good quality, that's one thing to avoid some waste in the production. Second thing is you have some waste because of finger jointing and planing of the lamella. So less planing means less waste during the production. And the first step is the production of the CLT master panel. So at the end of the day, we have to split the big master panel into single elements. So our technicians are investing a lot of time to prepare the nestings of the master panels in a way that the small single elements that are used in the project are nested into a master panel already in a way that we do not have waste during the CLT production. So therefore we use standard widths in our panel production. So we have a number of standard widths of the master panels, and then we try to optimize or to reduce the master panel sizes as good as possible with this nesting process to avoid waste during the CLT production. So these are the topics what we can do at the moment.
So it sounds like it's kind of like two visions. One is reduce the amount of waste, and the other is reuse the CLT at the end of its life at maybe the first building. So you can actually either take it back to the manufacturing and adjust it for a new building, or just put it right into a new building. Is that kind of the two visions?
Maybe, yeah. Why not? Yeah. So we will stay in the future, but this should be the goal at the end of the day. Yeah. So if a CLT building is demolished after some years, and if the elements are still in a good condition, then the aim should be to reuse these elements either again in the building, or at least to reuse these CLT elements again in the CLT production.
Yeah, I think this is a big hot topic right now. We had Andrew Law and Michael Green on the podcast in earlier episodes, and they both very much stressed the fact that if you look at the life cycle analysis of timber, specifically CLT, the biggest deterrent to the LCA is the end of life assumptions, because a lot of people think, oh, it's just going to go and decompose, or it's going to be chopped up for pellets. And that's really not the best use, because it's like there's so much energy and carbon that goes into making these big CLT panels that we should be able to reuse them and have the lifespan go from 75 to maybe 200 years.
Correct.
So, yeah. Do you think that if you had a CLT panel that, let's just say you had 50 of them come out of an old building, and someone wanted to bring them back to the manufacturing facility to maybe finger joint the actual panels, so you could create longer panels or a different dimension of panels, could you do that right now, or do you need to develop new technologies to be able to do that?
This could be one option, yeah. So at the moment, we do not have the machinery that would be able to finger join CLT elements. Therefore, you need a special machine. Such solutions are available on the market. So, for example, if you have glulam structures, there a big finger joint is already in use. Yeah, so the technique is available, and so this shouldn't be a huge problem. So this is one option could be one option to finger joint CLT and to get large elements from smaller elements and to finger joint them. This could be an option, yes.
Interesting. Have you had anyone come to you and ask you about that, or has CLT not been in use long enough to actually have this kind of end-of-life phase for some buildings?
At the moment, we, as you know, CLT is on the market since 25 years now. Yeah. So, and if we talk about the life cycle of a building, so we hope that, 50 years, 100 years are okay. So we had some questions for temporary buildings. So For example, if you deliver some CLT elements to exhibitions and you have to demolish the building after 6 months or 12 months, then the question is what to do with these elements. So at the moment, we would not be able to process these elements again in our factory. So that means at the moment, we should have a look on reuse of these elements for another type of building. But I'm sure that in the future, if this material is coming back to the production, then it must be possible also to use this material in the production again and again.
Yeah, very cool.
2 or 3 times we had the question, what can we do? Our CLT element is not long enough. For example, especially for office buildings, then maybe 16.5 meter in length is not long enough. So you need 18 or 20 meter long elements. And for these projects, our partner in Germany was already able to finger joint CLT to CLT. So our partner in Germany is already working with that equipment that is able to produce a big finger joint on the CLT elements and to glue CLT together. So this solution is available on the market.
Cool. Yeah, I didn't know that. That's awesome that it's already available. One thing as we talk about your partners, I know we said earlier that KLH doesn't produce other mass timber products like glulam or nail laminated timber or other mass timber elements. And so like on our project in Madison, we have glulam. And I know you're getting that from VHOG, but do you have other Austrian manufacturers or European manufacturers that you partner with for other elements?
Yeah, sure. So we have in the neighborhood we have different glulam producers, and we work together with them. So it depends on the project. You know that the glulam producers are also specialized somehow. So either they produce exclusively straight elements, or they are specialists in curved elements, or some special elements. So it depends a bit on the project. But we have nice and experienced glulam producers also in our neighborhood, and then we cooperate. So we cooperate on a project basis, and usually we organize and buy the glulams from the glulam producers and then deliver the package, glulam and CLT to the site.
And when you say you organize, do you also engineer both the CLT and the glulam typically in-house, or do you allow a third-party engineer to do this?
We have a small team of structural engineers that is able to do some structural design in-house, but it also depends on the project. Usually you have a project engineer that is doing the design on the glulams and on the CLT, and the project engineer is the responsible engineer at the end of the day. So our job usually is just to give some support if necessary, but the design is usually done by the project engineer.
Yeah, that's how our project is going. We have Equilibrium, who's a Canadian mass timber engineer that's doing all our
perfect. They're experienced. They know what they're doing. So that's good.
Yeah. The last segment I wanted to touch on is KLH working on any like big things that you could share with us right now or planning to in the future?
It's maybe not the big thing. It's a lot of different things we are working at the moment. So in Europe, we see that the fire topics are still under observation. So that means we are still involved in different compartment tests or in different research topics that are dealing with fire design. that's important to get more knowledge about the behavior of cross-laminated timber. Our aim is that the surface of the panels can remain bushflow as much as possible. So this is one big topic. The second big topic is, as I mentioned before, this reuse thing. To have scenarios for the end of life of the buildings. And in regard to reuse, how can we separate the CLT elements in a building? What about the design of the connections? How must the connections be designed to be able to separate CLT after 50 years, 100 years? And then also how to prove the quality on CLT that is 30 or 40 years old. Therefore, you also need to establish a guideline or rules how to prove the mechanical performance of CLT. Yeah, and the third big topic is prefabrication. So how to save time on site, how to protect the elements in a good way, so that additional work on site is not necessary. So we try to improve our logistics and our transports to avoid waste due to transportation. Yeah, we try to reduce the volume of packaging material. We try to reduce the volume of additional patterns or whatever is in between the CLT elements to reduce the volume of waste on site at the end of the day. Yeah, so different things are ongoing. And beside these topics, we assume that in the near future, additional wood species will come up that can be used for CLT production. So that means we are also doing some lab testing with other wood species, like hardwood or different softwood we cannot use at the moment. So yeah, different things are on our agenda.
You're working on a lot of things. It's awesome. One thing that I noticed when the CLT got to site, which I'm very excited about, is that the crane hooks were already pre-drilled into all the panels. And so, I mean, one thing I really like about using CLT is all the MEPs, their holes are already pre-drilled in the CNC machine in the factory. But even better than that, the crane hooks were installed. So I was watching the guys the other day, and they literally just brought the crane down, hooked the panel up, and it flew right into place. So it was really, really quick. So yeah, it's definitely been evident the amount of work and time and thought you guys have put into that, which is cool to see.
Yeah, that's in Europe. It's already a standard to apply also the lifting equipment, to apply lifting slings or whatever is needed to be able to assemble the elements. And very soon we also try to get an approval for the US market for our slings. So we will do some testing at the beginning of next year. So to get this equipment also certified for the US market. So this will coming very soon.
So we're using uncertified slings for our project?
No, it's always it's part of the design process, which kind of lifting equipment should be used on site.
Yeah.
And at the moment, most of the lifting equipments are again certified for the European market, but not all of them are certified for the US market. So that means some additional testing is required to be more flexible at the end of the day.
Oh, interesting. So the ones that we used for our project in the US are already US certified, or we got like an engineering judgment so that we could use them?
I'm not involved in that topic, so I need to check which lifting device is used in your project, but it is for sure proven. And as you know, as you have seen in our factory, we use different lifting devices. So either the slings or the slings with balls or other lifting devices that are available. And we do some testing on the latest lifting slings that were developed and that can be hidden in the CLT element. So this system will be proven again by beginning of next year.
Oh, wow. That's really cool. Yeah. I mean, it saves so much time for the guys who are working on site to be able to have those things already pre-installed. So,
Sure. Yeah. So health and safety on site is a very important topic. But not only on site, but also in our production facility. We also need to lift and to bring the elements to the truck or to the trailer. Yeah. So we also have some lifting processes at our factory, and health and safety is a huge topic for sure. Yeah. So everything must be safe and secured.
Yeah, that's awesome. Well, I know we're up here on time, but I really appreciate you joining and talking about these things. And I look forward to coming back over to Austria to seeing the new slings, hopefully soon.
Hope so too, yes.
Yeah. Well, thanks for the time today, Johannes, and good luck with your testing that you have to finish up here by end of day for your lamellas.
Yeah, thank you so much. Thank you for the invitation, and you're welcome to Austria anytime. Hope to see you soon again.
Yeah, of course. Bye.
Bye-bye.
At the Neutral Project, we're not just building structures. We're building a legacy of sustainability, helping align your investments with a sustainable future. We'd like to thank you for being part of this conversation. For more information and to stay up to date on how we're reshaping the future through environmentally conscious development, visit our social media accounts or our website at theneutralproject.com. Thanks again for tuning in, and we'll see you next time on the Neutral Podcast.